So the idea of hands-on, to me, it's the connection between the brain and the mind and learning.
Just wanted to make quick introduction about myself as well, and what we are trying to do, and what I'm trying to drive from this discussion with you, Mr. David. One is that as Lab of Future, we basically have started this as a concept to provide hands-on learning experience for students in space applications. We started as early as age group of 6-year-olds. So dividing them into 6 to 7 years, then 7 to 11, 11 to 14 years, 14 to 18 years, like that, group by group, but giving those curiosity boosters right at that tender age when they build up interest around space and how space can help humankind. So usually what happens is when we take general surveys and when we speak to people, space, the limited knowledge of space that people have is that everything that gets done in space is by the astronauts.
Yeah.
So if a child gets interested in space sciences, will end up becoming an astronaut.
Right.
Now, other than that, I mean, there are so many things around which we have to kind of educate them, make them aware, and excite them on different technologies of how to learn space sciences. So we introduced them to programs like Cube satellite design, HAB satellite design, CAN satellite design, this aero modeling, brain computing, space robotics, many programs we do. More than 1,000 activities have been created, and we give them this in our physical laboratories that we have created across the different places in India and in UAE. I'll just show you a quick 1 minute, 1.5 minute video just to showcase the kind of laboratories that we are giving for the kids. So just wanted to give you a glimpse. Basically, when students they come here, they are able to understand the application of the academics that they're learning in schools, and at the same time, all the projects that we create are themed around space. So they get more excited and more curious to learn more and know more about it. Now, something which excited me in your introduction mention is as a futurist. So I would want to know a little about yourself candidly, about your whole experience from your BSc in aerospace engineering from Boston to this journey of becoming now the CEO and co-founder of Arcesys. How did it happen, and what kind of skills helped you in shaping this journey?
Yeah. So you asked the question, what is a futurist? It's a rather strange word, right? I don't know. I've always been very curious about what is out there, and the whole idea that our planet is just it, and we're not going to be able to do anything else. That was a big question in my mind. So the thing that drives me is how do we, what will the future really look like once we get off the planet? And then the big question is, how do we get off the planet, right? How do we do that? How do we truly expand into the solar system and then eventually into the universe? So I was an aerospace engineer. Actually, I have a dual degree of aerospace and ocean engineering, but I chose to go up instead of down. Although I love the ocean. From a career standpoint, in terms of skill sets, an aerospace engineer really is like a jack of all trades. You can think of it as a system engineer, somebody who has to understand the entire system, but isn't necessarily an expert in every single piece, right? Most of my career has been in managing or working with highly specialized engineers in particular areas of electronics, of power systems, of propulsion, and then really getting them all to work together to actually come up with either a satellite or a rocket or some sort of space system. So, from my standpoint, if I go all the way back and I say futurist, I really like to think about things in the future and ask the questions why or why not. But then to execute, I became an aerospace engineer, which is the one that sort of puts everything together.
That's great. That's great, sir. So in your experience domains, sir, how do you see now this artificial intelligence and automation playing role in future of space exploration and satellite development, or the power systems engineers, these propulsion engineers? How is AI going to shape that? What advancements you think are happening in the industry?
So it's important to sort of separate what we all think of as artificial intelligence, which is some robot, walking and doing our jobs all the time, to what we currently use, which is automation. And the other word we use is autonomy. So today, you could argue that in the span of artificial intelligence, we have been executing autonomy and autonomous systems for the last 20 years. The need and the specific requirement when something is launched into space and it does not have a human component to it, which there are tens of thousands of those, requires onboard ability for it to understand what's happening to its own sensors, to its own systems, and then respond to whatever's happening to make sure it stays alive. That process is really autonomous because we're not telling it, hey, you need to do this. And then the action of it executing is autonomy. So from that standpoint, the question becomes, as we grow in the scale of being more artificial intelligence, being able to do more with computational systems on board, the question then becomes, what is it that our AI is going to apply? The interesting thing is that AI in space will allow for a much faster and more robust response to problems. So you can sort of think of it as the spacecraft will be able to heal itself, right? That's what AI will bring. The other thing that it'll do is it may compartmentalize some of the really difficult challenges. As an example, when cameras go up to spacecraft and they take an image, that image is a big file, and you want to do something to that image. So that's typically image processing. AI can actually help speed that up and provide only the data that is being looked for in that image to send down, which means the entire operation is more efficient. Now that's one spectrum of autonomy and autonomous systems. The far spectrum is, once humans start to go up, then what artificial intelligence will do, will be able to support the life science system or the power distribution system, so that humans don't have to constantly be checking those kinds of things.
Yeah, so autonomously it becomes a support system for human exploration there.
Basically,
Absolutely.
yes. Yeah.
So you founded this Millennium Space Systems, which later became a part of Boeing. What were the those key factors in successfully growing a satellite business, and what advice you have for these young ones of the way they look at becoming those aspiring entrepreneurs in aerospace industry?
There is no question that starting a business is not easy. Starting a business in the space industry is really hard. That's sort of the first part. My first foray.
That's the part.
Yeah. My first foray into business, being an entrepreneur, was I started a company called Vanguard Space with an ex-Apollo astronaut, and it was incorporated in Germany, and it was going to be the very first space servicing company that was out there. I think we were before our time, because the biggest trick, the biggest challenge, honestly, to get a business going, if you're an engineer, is to take your engineering hat off and you have to put a business hat on. They don't always agree with each other.
I can relate to it, sir.
Yes. As an engineer, I look at things very logically. I try to solve problems. I convey information that I believe is important enough to talk with other either investors or business leaders. But what's interesting is in that arena, I'm talking engineering as opposed to business. So I can tell you that one of the most difficult things in starting a business is trying to resolve those two communication styles. Because when talking to investors or even to within the government, if you want to convince on a proposal, you have to take a step back up and you have to present the big picture and the vision and what it's going to do for the long run. Not, oh, my thing is the coolest thing in the world and you've got to give me money for that, right? That's I would say that dichotomy is the toughest thing to get over.
But you were fortunate enough to get one of the giants like Boeing supporting the whole project.
I was lucky. Yes.
That's great, sir. Sir, coming to students, students these days, they have got so much of possible exploration opportunities in space sciences itself. So as the director of USC Space Engineering Research Center, while you were playing a key role in developing hands-on, these satellite projects for students, how important do you think are these practical and hands-on experience for students in engineering and in high school and the younger ones? And what impact do you think these programs will have eventually in the industry?
I'm a firm believer in hands-on learning. Absolutely firm believer. I lament the fact that many years ago in high school, the vocational hands-on attributes in the United States, at least, translated out. They're slowly coming back in, which is good. There's something that happens when between the brain and the mind and your hands when you're actually putting something together. And it's not something that you could teach in a classroom, right? You have to go do it. There's the famous mission director from Apollo. He wrote a book. It was called "Failure is Not an Option." Right? Great, wonderful. Yeah. For human-rated activities, I would agree that's the case. For everything else, if you haven't failed at something at least once, I don't believe in any way that you have learned the fundamentals of what goes into making a project or creating an engineering solution. It's the process by which you go through. So I'm a real big believer, and my hat's off to you in terms of the lab of the future relative to starting younger. And today there's so many new technologies that are very low cost, and it starts with robotics. And some people might ask, well, how does a little itty bitty robot that sits on a table have anything to do with the thing that you see in the background, right? Big space thing. Right. The fact is that everything on a spacecraft still connects through electrons and electronics and data that flows back and forth. So starting out even at the smallest level of how to control motors and actuators and cameras and interface with battery systems, all of that is absolutely critical, and it will follow a student all the way through their career. No question about it. The Space Engineering Research Center, I specifically focus on hands-on activities. We've been lucky enough that we've done anything from a lunar lander prototype vehicle that uses a turbine engine in the middle of it to lift itself off, that was modeled after an Apollo program, and it was very successful. We built CubeSats. Obviously, CubeSats are small satellites, about yay big. That makes sense, right? But we've also now expanded into new technologies that are going to be needed in space for us to really thrive and go forward, whether it be space robotics. We just demonstrated a couple of weeks ago a rendezvous system that is inside the International Space Station that's flying on these little things called astrobees, right? What's interesting with students is even at the lower levels, they can begin to experience elements of zero gravity on what's called an air-bearing table. I mean, you can make very simple things where you can see what happens when things float and you try to touch them and they float away, right? That's space. So you can actually execute very simple things to get not only the concepts across, but also to begin to test really cool ideas that some of the students might have. So the idea of hands-on, to me, it's the connection between the brain and the mind and learning and the visceral activity of actually building something, putting wires together, putting motors together, making things work.
Fantastic, sir. I think this is one of the most insightful answers I've ever heard on hands-on learning. It's going to answer a lot of queries which usually, parents of young ones have. That why it is so important to have hands-on learning skills, because eventually theory will play the role in their lives. But I think you said it right. What is taught inside the classrooms, unless and until practiced live, it really doesn't give that insight to a child of how to use this, how to apply it.
That's right. Yeah, that's right.
I would also like to ask you, sir, in terms of extending any kind of research opportunities or internship opportunities, or kind of a some mentorship, some guidance for the students who are working on these projects. Are there any kind of possibilities available with ArcSys, or something which you can suggest?
It's much easier. So, as an example, with the Space Engineering Research Center, I actually host international students quite often. I have a number that come over almost every year from Europe. USC is a very international arena, so that's actually good. Happy to provide any kind of mentoring that we could do on a project basis. So I've actually worked with universities in Taiwan and in Australia and New Zealand with students where we had sort of a joint program that was being worked together. The other thing to consider is that in the US, there's a number of student challenges that NASA or other things put out. Now, typically they require the host university to be a US university, but they invite that university. They can have a team anywhere around the world. So that's absolutely possible. I've done that before, actually twice. Nice. The other thing is at the different level, right? Does it have to be at the university level? No, it doesn't. I sponsored 2 high school projects that were here in the United States to help mentor them. We actually put in a proposal. They got a little bit of grant funding to go forward and do things. So yeah, I'm absolutely happy to do that. We could explore almost any direction. What I'm also happy to give potentially a hands-on, I hate to say lecture because it's really boring, right? But I have enough lab space that we could actually do little hands-on demonstrations that may be able to convey to the students. They could do the same thing if you could have some small materials that would support that. Yeah.
Absolutely. This is so supportful, sir. We were doing some microgravity experiments here in the lab, and the way students started to explore more on it was super amazing to see. They started doing flame testing, combustion testing, chemical reactions testing, how do molecules behave in microgravity. So much of vibrancy happened other than physics. Chemistry and biology also came into action while they started to do these tests. So
that's awesome.
That is something, sir, I personally look forward to in terms of establishing a bridge, a connection between Lab of Future and ArcSys, and trying to give these opportunities to the UG students who are looking forward to this, as well as some of them to high school students, because many of them are very interested. They are very much exposed to the right set of resources, but at the same time, they are little not clear with the career pathway and the channel, what to take from where. So we try to bridge that gap and bring them on a platform wherein they get exposed to the right resources.
Got it. Yeah, happy to help with them. I mean, that's the younger generation's a little bit more difficult to do unless you're in, right there with them, right? But the high school students from sophomore up, happy to do, whatever we can do remotely to convey and convince them, as well as to sort of show them the breadth of things that are out there that they could actually participate in.
That's great, sir. So in this particular thing, sir, if we like kind of invite a lot of school leaders and some students to join a kind of a webinar, or a webinar would be good, wherein we can start creating these boosters and spikes of curiosity to them, and then from there we take them and shortlist them based on a criteria for a particular project, and then lead their ways forward. So how do you find this as an idea? Should be good.
Yeah. I concur. I believe that would be the right approach. Yeah.
That's great, sir. That's great. Okay, sir. I think I just wanted to make this introduction with you just to know a little about yourself from this angle of your experience. And you're also joining the event in Milan in October.
Yeah, we have Arcasys. I have a booth there, and then I have five students that are coming from the university to give presentations. Yeah.
So I'm also planning to travel, sir. I think it will be a great opportunity to meet you there.
Oh, great. Yes.
Yeah.
Yes. Yeah. That'd be awesome. Great. Yeah, we're gonna have hardware there. We're gonna have a robotic arm. Yeah, we're gonna be doing stuff. Yeah. Should be fun.
Okay, that's great. So in terms of operations, Arcasys is right now operating in US?
We do have a small subsidiary in New Zealand, and the intention was to reach out into Oceania potentially. I'm looking to potentially start one in the UK, in England. I'm actually I'm hoping to get a pitch session invite to Singapore to come in November. And, again, always looking for funding internationally. So I've been to Dubai many times, but I haven't thought about opening anything there. Although I know the space ecosystem is now stronger. Yeah. I was there a couple of years ago and it wasn't really taken off yet. Now it seems to. So, yeah.
I think next 10 years are exciting in UAE because UAE government has created a UAE national space strategies, and they are keenly working on it. They are promoting this whole ecosystem. So, I think as a market, it's growing.
Yeah, that's great. I need to try to go back and maybe tap into that. Yeah.
Next time when you are in Dubai, so you have a place. You have a place to visit. You have a place to stay.
I appreciate it. Yeah, no, I appreciate it. Awesome.
That's great, sir. So I'll not take much of your time, sir. Today I'll be writing to you a few of the takeaways from this session. So nice speaking with you. Thank you so much, sir. Thanks for taking out time.
Cheers. Have a wonderful day.